In a single strike, a ground robot packed with explosives erased an entire Russian defensive position, and not one Ukrainian soldier had to rush forward under fire. That moment matters because it shows how the battlefield in Ukraine is changing right now, not in some distant future scenario discussed by military planners. Unmanned ground robots are no longer limited to carrying supplies or evacuating wounded troops, and they are now being pushed straight into the most dangerous zone of the front line. One such robot moved through difficult terrain under the threat of Russian drones, reached a fortified shelter, and detonated its payload before infantry stepped in to secure the area. For Russian forces, this was not just another loss of personnel or equipment, but a direct shock to the logic of frontline defense, where deep trenches and hardened shelters were supposed to provide safety. If a machine can reach those positions first, then the idea of a protected rear line starts to fall apart. Cheap machines taking the place of human attackers begin to change the math of that fight. What comes next is not simply a story about a robot explosion, but about how technology is being used to offset manpower gaps and force the opponent to pay a higher price. The central question now is simple. Was this a one-time strike, or the opening move of a battlefield where robots lead and humans follow? The attack unfolded as a controlled sequence where a machine was sent to face danger that usually falls on infantry, and that choice reshaped every step that followed. According to Ukrainian accounts, the unmanned ground vehicle moved forward across broken ground where tracks, mud, and debris slow human units and expose them to constant observation from above. The area was already under pressure from Russian drones, which meant any visible movement risked detection and rapid fire. Yet the robot kept moving because it did not need cover in the same way a soldier does. As it advanced, the UGV followed a narrow route shaped by terrain and previous fighting, using low profiles and pauses to avoid drawing attention from the air. This was not a fast charge, but a steady approach designed to reach the target without triggering an early response, and that patience mattered more than speed. Russian soldiers remained inside their shelter, which is a normal reaction under drone threat, because staying underground often feels safer than moving in the open. That habit turned into a weakness once the robot reached close range, since the position was prepared to resist infantry assault. Not an explosive device delivered directly to its entrance. When the UGV arrived at the shelter, the explosive payload was detonated at close distance, and the effect was immediate. The blast focused its force inward, collapsing cover, flooding the confined space with shock and debris, and leaving little room for an organized response from the soldiers inside. This moment marked the key shift in the engagement, because the most dangerous phase of an attack was completed without exposing Ukrainian troops. No squad had to sprint forward under fire. No breaching team had to approach the entrance, and no medic had to wait behind cover for casualties to be dragged back. Only after the explosion did Ukrainian infantry move, and that timing was deliberate. By entering after the detonation, the troops faced a cleared or disrupted position rather than a prepared defense, which reduced the chance of close-range ambush and sudden losses. The soldiers advanced to secure the area, check for survivors, and confirm control, but the risk profile had already changed. Instead of absorbing the first shock, they stepped into a space where resistance had been broken by a machine that could be replaced more easily than trained personnel. This sequence highlights how the order of movement now matters as much as firepower. Sending a robot first turned a high-cost assault into a lower-risk operation, and that choice reshaped how time, space, and exposure were managed during the fight. The attack also shows how pressure from the air influences ground decisions on both sides. Russian drone presence pushed defenders underground, while Ukrainian awareness of that pattern allowed planners to select a method that exploited it. Every step was built around avoiding early contact, forcing the enemy to stay passive, and striking only when the robot was already inside the danger zone. This is why the event matters beyond a single position. If machines can take on the role of first contact, then the classic image of infantry leading the assault begins to fade, especially in areas watched constantly by drones. The question that follows is not about technology alone, but about choice. If a robot can absorb the highest risk part of the mission, how many future assaults will still ask soldiers to go first? The weapon at the center of this strike was not new, but the way it was used changed its meaning on the battlefield. The TM-62 is a Soviet-era anti-tank mine built to destroy armored vehicles, and it was designed around one simple idea: deliver a large explosive force with reliability rather than precision. Its wide casing and heavy charge made it a standard tool for blocking roads and stopping advances, and large stocks of these mines still exist because they were produced in huge numbers during the Cold War. In this attack, that original role was pushed aside. Instead of waiting underground for a vehicle to pass, the TM-62 was carried forward and placed where soldiers believed they were protected, turning a defensive weapon into an offensive one. This shift matters because the explosive effect of the mine does not depend on speed or accuracy. Once the charge is placed close to a confined space, the blast pressure has nowhere to escape, which makes shelters and dugouts especially vulnerable. It can be dropped from aerial drones, attached to remote platforms, or set off in positions meant to resist infantry assault, which shows how flexible a simple design can become under pressure. That outcome highlights a key advantage of using such munitions in this role. The mine does not need a direct hit on a vehicle or a perfect placement, since proximity alone delivers the destructive effect required to break resistance. From the defender perspective, this creates a dangerous mismatch. A shelter designed to withstand fragments and small arms fire offers little protection against a heavy charge placed at close range, especially when there is no warning from incoming infantry. The use of TM-62 in this way also fits the realities of drone-dominated combat. Movement above ground is constantly watched, and any group trying to carry large explosives on foot risks detection long before reaching the target. By loading the mine onto an unmanned ground vehicle, that risk is shifted away from soldiers. The platform can move slowly, pause when needed, and continue even under threat because there is no human life at stake if it is lost. This approach turns availability into advantage. A widely produced mine becomes a flexible tool for breaking strong points, and the lack of complexity makes it easier to integrate into different systems. What stands out is not innovation in materials, but innovation in thinking. Ukraine is not relying on rare or expensive munitions to achieve this effect, but on reassigning an old weapon to a new mission. That choice also complicates the defensive picture for Russian forces. If a familiar mine can arrive in unexpected ways, then predicting threats becomes harder, and every shelter entrance turns into a potential vulnerability. The uncertainty around how many mines were used reinforces this pressure. Defenders cannot plan around a fixed number, because the real danger comes from the method rather than the count. This is why the TM-62 matters in this attack. It shows how a basic explosive device, when paired with unmanned delivery, can challenge assumptions about safety and force a rethink of how ground defenses are built and held. The shift from logistics to direct attack marks a clear change in how unmanned ground vehicles are being used on the battlefield, and that change did not happen by accident. For much of the war, UGVs operated quietly in the background, moving ammunition, food, and medical supplies through areas watched constantly by Russian drones. These missions mattered because they kept soldiers alive, yet they followed a familiar pattern where machines supported combat but did not shape it. That boundary has now been crossed. When a UGV is sent forward as the first element of an assault, the machine stops being a helper and becomes the opening move, and that decision changes how commanders think about risk. In areas where Russian UAV coverage is dense, moving people is dangerous even before the first shot is fired. A supply run can draw attention, a medical evacuation can trigger an ambush, and any group that pauses too long becomes a target from the air. UGVs were introduced to solve that problem by reducing exposure, and once that logic proved reliable, it became harder to justify keeping machines out of combat roles. If a robot can survive a supply run under drone threat, Then it can also approach a fortified position where soldiers would face the same danger. The recent attack shows how this thinking plays out in real time. Instead of asking infantry to close distance under constant surveillance, Ukraine sent a machine that could absorb loss without political or human cost. This is not about replacing soldiers, but about reordering tasks. The highest risk phase of an operation is now assigned to equipment, while people move only after conditions shift in their favor. That adjustment fits the reality of a long war, where every trained fighter matters. Repeated infantry assaults drain manpower, reduce morale, and limit the ability to hold ground later, even when tactical gains are achieved. By contrast, a UGV can be repaired, rebuilt, or replaced with far less impact on unit readiness. Its loss is measured in hardware rather than lives, which changes how often commanders are willing to attempt difficult maneuvers. The battlefield itself reinforces this trend. Constant drone presence compresses time and space, making traditional movement slower and more dangerous, while machines that do not panic or tire can wait for the right moment to act. Once UGVs proved reliable in logistics, the next step was inevitable. Their ability to move unseen, carry heavy loads, and operate remotely made them suitable for tasks once reserved for assault teams. Early in the war, ground robots were treated as fragile assets, but repeated use hardened designs and improved control, which reduced hesitation about placing them in danger. As planners' confidence grew, their role expanded. A platform that once delivered bandages now delivers explosives, and the same path that carried food can carry a strike package. This does not mean every mission will rely on machines, but it shows a clear direction. UGVs are being pulled closer to the point of contact because the cost of doing so is lower than the cost of sending people first. The longer the conflict lasts, the stronger this incentive becomes. Each assault that avoids early casualties preserves combat power for later stages, which matters in a fight measured in months rather than days. The result is a battlefield where support tools evolve into combat tools through necessity. UGVs have crossed their old boundary because the conditions of the war demand it, and once that line is crossed, there is little reason to step back. Manpower pressure sits behind every tactical choice Ukraine makes, and that pressure shapes why unmanned ground vehicles are now being pushed into roles once reserved for infantry. Ukraine faces a clear disadvantage in available troops compared to Russia, and that imbalance becomes most dangerous during direct assaults, where losses rise quickly. Every attack that requires soldiers to cross open ground under observation carries a cost that cannot be easily replaced, especially in a war that does not pause to allow recovery. This reality turns manpower into a strategic resource rather than just a number. Each trained soldier represents months of preparation, experience under fire, and the ability to hold terrain once it is taken. Direct assaults consume that resource fast. Even successful attacks often leave units weakened, forcing commanders to choose between pressing forward or consolidating with fewer people than planned. That is where UGVs change the calculation. A machine can be sent into a high-risk task without the same long-term consequences, and its loss does not reduce the pool of trained fighters available for future operations. The cost difference is not only financial, but operational. Replacing equipment is faster than replacing people, and damaged hardware does not carry the emotional weight that casualties impose on units and society. In practical terms, this allows Ukraine to attempt actions that would otherwise be postponed or cancelled. A dangerous approach route, a suspected strongpoint, or a defended shelter can be tested by a robot before a soldier ever steps forward. This does not remove risk, but it shifts where that risk is absorbed. Instead of spending human lives to learn where defenses are strongest, Ukraine spends machines to open space for movement. That shift matters most in a war of attrition. When fighting stretches across months and years, preserving manpower becomes as important as seizing ground. UGVs support that goal by taking on tasks that expose soldiers to the highest danger with the lowest strategic return. Breaching, probing, and first contact fall into this category because they carry high risk but do not always require human judgment at the point of impact. At the same time, robots do not replace infantry where people are still essential. Holding territory, adapting to sudden changes, and interacting with complex terrain still depend on trained troops who can think and react in ways machines cannot. The balance comes from dividing labor. Machines handle the most predictable and hazardous steps, while soldiers focus on control, coordination, and decision-making once conditions improve. The use of UGVs in attack roles should be seen through this lens. It is not a symbol of automation for its own sake, but a response to the math of attrition where survival and endurance decide outcomes. Robots do not win wars alone. They do, however, buy time, protect people, and reshape how risk is managed on the battlefield. In a conflict defined by long pressure rather than quick breakthroughs, that ability may matter as much as firepower. The use of unmanned ground vehicles as attack tools forces a shift in how Russia's defensive positions are built and defended, and that shift is already visible on the battlefield. Positions that once felt secure against infantry assaults now face a different kind of threat. Trenches, dugouts, and reinforced shelters were designed to slow soldiers, absorb small arms fire, and survive indirect strikes. But they are far less prepared for explosives delivered directly to their entrances by machines. When a UGV can approach without fear, the idea of a safe interior space begins to collapse. Russian soldiers are pushed into a dilemma where staying underground may invite destruction, while moving outside exposes them to drones and fire from above. This pressure changes how Russian units must deploy their forces. Instead of concentrating manpower inside strongpoints, they may need to spread out, which reduces the strength of any single position and complicates command and control. Dispersal comes with its own risks. Smaller groups are harder to coordinate, easier to isolate, and more vulnerable to being overwhelmed once contact begins. To counter the growing role of UGVs, Russian forces are likely to lean harder on detection and disruption. UAV patrols become more important, not just to watch the sky, but to scan the ground for slow-moving platforms that do not fit traditional movement patterns. Electronic warfare also takes on a larger role. If communication links can be jammed or confused, an unmanned vehicle may stop, lose control, or fail before reaching its target. This pushes resources into systems that compete for attention and funding. More drones, more jamming equipment, and more countermeasures mean fewer assets available for direct combat tasks. The response does not end there. Physical barriers, improvised obstacles, and layered defenses may return to areas where they had been reduced, as defenders try to block or funnel robotic movement. Yet every added layer increases complexity. More obstacles slow friendly movement, more sensors demand operators, and more systems raise the chance of failure under pressure. The broader effect is a shift in tempo. When both sides adjust to machines entering the fight, the pace of operations can change as each waits to see how the other adapts. This is no longer only a contest of territory. It becomes a test of learning speed, where the side that adjusts faster gains short-term advantage before the balance shifts again. The presence of UGVs also alters decision-making at higher levels. Commanders must now consider threats that do not tire, do not panic, and can be sacrificed without political cost. That reality makes risk calculation colder and more mechanical. An attack that might have been judged too costly with troops can be approved when a machine leads the way. At the same time, reliance on robots creates new vulnerabilities. If control systems fail or countermeasures improve, a tactic that works today may fail tomorrow. This constant adjustment turns the conflict into a moving target. Each success invites a response, and each response forces another change in approach. What emerges is a contest between human judgment and mechanical execution. People decide when and where to act, while machines carry out the most dangerous steps. The clash is no longer defined only by Ukraine versus Russia. It is shaped by how quickly each side can blend technology with tactics and turn adaptation into advantage. The outcome of that race remains open. As unmanned systems spread across the battlefield, the question is not whether countermeasures will appear, but how fast they will close the gap. That leaves one final thought hanging in the air. How long will it take before the next response reshapes the fight once again? The ground robot strike sends a clear signal that the war in Ukraine is no longer following familiar rules, and the shift is happening in real time rather than in theory. A machine moved first, absorbed the highest risk, and opened the way for soldiers to advance with fewer losses, which shows how unmanned systems are changing the order of battle. UGVs are no longer limited to support roles, and they are now being used to reduce manpower strain, preserve combat strength, and keep pressure on Russian forces without asking infantry to pay the full price. This approach fits the reality of a long and exhausting conflict. Ukraine faces limits in personnel, while Russia relies on depth and endurance, so every tool that changes the cost of an assault carries strategic weight. What is unfolding is not just a contest of weapons, but a test of learning speed. The side that adjusts faster gains ground for a moment, until the balance shifts again. That leaves an open question hanging over the battlefield. Will unmanned systems remain helpers that take the first risk? Or will they begin to shape how wars are planned and fought from the start? The answer is not settled yet, and that uncertainty is part of what makes this moment important. If this analysis matters, support military force by liking the video, sharing it, and subscribing to the channel.